Hi, good afternoon, everyone. Thanks for joining us. My name is Lin Han, in charge of community engagement here at Hyperganic. Before we begin, kindly be reminded that this webinar will be recorded, and by participating, you consent to being recorded. The recording will be shared with you after the webinar. For questions and answers, we value your active participation. Feel free to ask questions or share insights using the chat feature that you can find at the top of the ribbon in Microsoft Teams. Our team will also address your questions during the Q&A session at the end of the webinar. Now, your mics and cameras have been turned off during the presentation, but we will unmute your mic during the Q&A session should you choose to ask your question verbally. And finally, after this webinar, we will send you the recording together with some follow-up information. Now, today is a really special day to us and our partners, as we're here to officially unveil HyDesign, our cloud-native design application that makes 3D printed lattices effortless. Coming up next, we'll cover what are 3D printed lattice structures, why we're seeing more of them, and most importantly, why it's been so challenging to design lattices and implement them in products. Together with our partner from Forward AM, we will share how we've been trying to solve these challenges through the UltraSim 3D lattice library and HyDesign. We will also hear from users about how HyDesign has helped them in their product development journeys before seeing HyDesign in action during our live demo. Then hear about our vision for HyDesign and how we are improving it even further. Of course, we'll tell you all about how to get started with HyDesign before finally answering your questions in a dedicated Q&A sessions. To help kick things off, I'd like to give the stage to Marius from Forward AM. Marius, please.
Thank you very much, Dinhan, and also a warm welcome from my side. My name is Marius. I am the product manager at AM Services at BSF Forward AM, and I'm very excited to be here today, having worked now with Hyperganic already for several years, and today participating finally in the commercial launch of the new software solution HyDesign. And I'm particularly excited because today marks a great milestone in achieving our vision, which is to make lattice application development much easier and more accessible by combining materials with software. Because BSF Forward AM is foremost a material manufacturing company. We develop and produce 3D printing materials in forms of filaments, resins, and powders. But we do more than that. We do more than just materials. We actually develop applications together with our customers from the initial idea to the finished commercial product. And we do this by using AM services such as design, simulation, testing, and scale-up. And partnering together with Hyperganic combines our expertise in materials and lattices together with Hyperganic's great expertise in software and creates a solution that makes lattice application development much, much easier. And this way, more users can experience of the benefits of lattices. Now, what those benefits are, I'm going to explain in a second. For everyone who is not as familiar with lattices, briefly explained, lattices are structures with repeating patterns of interconnected elements. It's nothing new. It's not something that is, let's say, only 3D printing specific, but you will actually, in fact, find this everywhere in nature around you. You find those structures, for instance, in minerals with a diamond structure. You find this in plants. You find those in beehives. You find a grid structure, which is a lattice structure, also in a fence around your house. So they basically surround you. And they typically serve several different purposes. The open framework of lattice structures promote better airflow, which aids to passive cooling, allowing heat to dissipate more effectively. Lattice structures offer typically a very modern and visually appealing look, so it also promotes very much the aesthetic point. The lattice structures typically provide a structural support to withstand mechanical stress, while at the same time optimizing material usage for lightweight. And by changing the lattice design within your part, you can achieve with one material multiple behaviors. And these structures increasingly, let's say, are getting increasingly interesting across all different kinds of industries. We find more and more of these lattice applications out there. You find those structures incorporated, for instance, in consumer goods, such as bike saddles, such as footwear applications. You find those in helmets, but you also find those in the O&P industry, used for customized insoles or prosthetic sockets. You also find lattice structures in the transportation industry, used for lightweight components such as those seat elements, interior panels, brackets, and more. And honestly, I think there could be even more, because as interesting as lattice applications are, the development is not that easy. I personally think it is still too difficult and it needs to be easier. And ever since we from BSF4DM looked into lattice structures around 5 years ago, we supported and consulted a lot of companies on their development work. And oftentimes what we see is when companies start with having this idea of replacing a foam with a 3D printed lattice structures, they quickly drift off in what we call the lattice road to hell, because there are so many different challenges along the way that you need to solve in order to reach a desired outcome. You have, for instance, you need to identify what is the right material, what's the right machine that is compatible with this material. You have to identify what is a lattice structure that fulfills the requirements, and lattice structures, they behave completely differently. So you open up a universe of different lattices. You have to allocate resources to the project, hiring expert designers and engineers. You have to invest into, expensive software, and then start designing, printing, testing, and really understanding that the lattice structures out there. And it causes a lot of, frustration. And in the end, basically takes a lot of time and resources until you reach a desired result. And we have been through the same challenge. And we believe that this shouldn't be the case. The lattice application development shouldn't be that difficult. So we tried it by trying to solve two things. On the first side, we came up with the UltraSim 3D lattice library, which is publicly available and contains the results of the lattice research of us over the past 5 years. They contain pre-selected, validated lattices that allow you to quickly filter what lattices works for what application. What we did is we designed and printed and tested lattice structures, characterized them to understand the behavior, and then build up a material model for our nonlinear TPU, used additionally simulation to increase the number of data points, and now matched the behavior of the lattices with the requirements of applications. So this way, you can now filter within this lattice library by applications, for instance, footwear, seating, and protection, what lattices work best. And you have the full characterization with the in-depth technical requirements, such as show hardness, the stiffness, the compression stiffness over certain rates, and so on. And in addition, we made a manufacturing check, which makes sure that all of these lattices are printable, that they're depowderable, and the beams don't break. Now, the second thing that we did is we partnered up together with Hyperganic to make the lattice design much easier, because with the lattice library, what you can do is you can filter and identify the right lattices. But with HyDesign, now you can take the filtered and the identified lattices and add it into your design in a very user-friendly way. And now how this works and what additional features HyDesign has is something I want to now hand over to Michael.
Thank you, Marius. Hello, everyone, and thank you for participating in our launch event for HyDesign today. My name is Michael Robinson, and I have been CTO at Hyperganic for almost a year now. For many years, Hyperganic has been a pioneer in developing algorithmic engineering solutions for complex 3D printed applications. We continue to work with customers around the world every day to help develop innovative engineering solutions for many different additive manufacturing opportunities. I'm delighted to be part of the team bringing the advanced geometry and simulation capabilities that we have developed over the years into our new publicly available cloud-based design application, HyDesign. Our product vision for HyDesign is an accessible, easy to use, affordably priced application for developing advanced and optimized parts that take advantage of the capabilities that are offered by additive manufacturing. With HyDesign, we are working to lower the barriers to designing sophisticated 3D printed parts. HyDesign is a cloud-based application. Anybody with a browser can start producing designs almost immediately. As Marius has discussed earlier, the integration of the validated Lattice library from Forward-AM gives product designers a significant head start in getting to reliable, functional, and use parts. HyDesign provides a full set of beam lattice and TPMS structures and gives users fine control over the detailed properties for these structures, such as applying blended gradients between different TPMS structures or modulating geometric properties such as wall thickness, unit cell size, bias, etc. This allows designers and engineers to get the exact material and aesthetic properties desired. We are continuing to invest in bringing further such capabilities to HyDesign in coming weeks and months. Today, we are very excited to introduce integrated structural simulation in this release of HyDesign. This is a significant milestone on our product roadmap. This integration allows designers and engineers to directly run structural simulations in HyDesign without a separate geometry meshing step and without exporting to separate simulation software. We have plans for a full suite of multi-physics simulation capabilities in HyDesign. The first of these is static linear elastic stress-strain analysis, which we are releasing today as a beta feature. The simulations are set up within HyDesign and run on our servers. The simulation results are displayed and inspected using the same user interface. Here we see a brief overview of the end-to-end simulation process. First, in this example, import your base part and apply a TPMS infill. Next, switch to the simulation module, apply boundary conditions to the part, and refine the boundary geometry. Finally, submit the simulation and view the results in HyDesign when the simulation is complete. Here we see a sample of some of the most popular features in HyDesign. Shell allows you to import a solid model from an external source, and from that source object, create a hollow shell with a user-defined wall thickness. Forward-AM Lattice allows you to fill a shape with one of the material and lattice geometry combinations from the Forward-AM Lattice library to give your part validated metamaterial properties. Image modulation is a powerful feature that allows you to project a grayscale image map onto a lattice and use that map to adjust the beam thicknesses to fine-tune the stiffness or flexibility of the lattice structure at different locations on your part. TPMS stands for Triply Periodic Minimum Surface, which is a family of curved space-filling surfaces such as the popular gyroid. HyDesign includes a full library of TPMS structures. And with Add Pattern, not only can you select different TPMS structures in HyDesign, but you can combine different TPMS structures together with a gradient blend for complete control over the physical and aesthetic properties of your part. Modulate gives you fine control over the TPMS properties, such as wall thickness and unit cell size. Skin allows you to project an image map onto the surface of an object to apply a skin with the desired outline and thickness. This is very useful for designing contact surfaces, such as seen here in the bicycle saddle example. Emboss is similar to skin, but uses a grayscale image map to remove material from the surface of an object to a specified variable depth, creating any desired surface texture. And we've seen the simulation example just now. So that's an overview of the HyDesign application. Next, we'll see a few examples of the types of products that designers are developing today with HyDesign, followed by a live demo.
Thank you, Michael. Now, exactly what kind of parts has HyDesign been used to design? Let's first hear from Carlo, founder of PADIC and 3D printing enthusiast, about his project.
Hi, I'm Carlo from PADIC Kiteboarding. We partnered up with HyDesign and Forward AM to create a new kind of kitesurfing pad. This kitesurfing pad will be 3D printed, which gives us a huge advantage in riding comfort and performance. So lattice structuring in the kitesurfing pad gives us a huge advantage that we can now adapt the damping properties to the rider. So from a girl with around 40 kilos to a huge guy around 100 kilos, we can achieve like a unique damping properties will increase the riding comfort and the performance on the water. HyDesign is really comfortable to use. You just import your volume files, and then within seconds, you get a lattice structure which you can forward to work on. I like the speed of the program, and we will continue to work on it. The special thing about HyDesign is you always have somebody to talk to, and they are willing and they're really helpful with every question you have. So there was no question which was unanswered. I like the company stuff and working together with them. I really enjoy it.
Now with PADIC's kitesurfing pads, we can see the synergy between Forward AM's material expertise, Hyperganic's software capabilities and technology, as well as the keen user-driven design by Carlo and his team. Next, I'd like to give the floor to David Medina, automotive 3D designer and former road cyclist, to share a little bit about his project. David, please.
I'm doing seating, so this is my area of specialty, and I wanted to share with you how HyDesign helped me to transform my saddle project. The saddle started when I was doing a master thesis. At that time, 2020, I was doing a lot of online racing on the bike at my garage. So I started to having saddle issues related, like perineal numbness, things like this. And I noticed many people were having similar issues. So that is why I started to make saddles. The first challenge I faced was limitations in terms of time and resources. So I really needed to speed up my process. So I would focus more on the creative side, research, and the collaboration, and less spending time on technical issues, technicalities from 3D modeling. So I end up doing some new workflows, combining implicit modeling with polygon modeling techniques. At that time, I was testing a lot of different type of lattice design tools, but I still was struggling with getting functional lattices like the ones you see on the screen. And I was worried about also licensing. Nothing was convenient. So I was nearly to give up on the project. Then finally this year, I discovered HyDesign, and I joined the public beta testing. And I found it was really quite convenient, easy to learn with a very quick learning curve. The convenient features I found was the built-in lattice libraries with the lattice paths really helped me to improve the prototyping workflow, giving me direct feedback. That was very good. And also the cloud computing, this saves me a lot from blue screens. So I would have more time to dedicate to the creative work. So finally, I can do functional prototypes like the ones I have shown before. Maybe you can see a little bit here. And still 60% functional, let's say end user grade functional. I mean, but it's really good results. I can get really ready printing, ready for 3D printing just without post production. So it is great. And next, I will move to make more functional products tested with the users to solve the saddle-related issues during the stationary cycling. And the materials I will use will be Ultrasin TPU01 with vapor smoothing. I like it, the touch very much. And the PA 11 and 12 from all of them from BASF, and with multi-fusion, multi-jet fusion technology. And yes, super excited, a lot to do. So yeah, let's keep moving forward. And yeah, thank you for your attention. Feel free to contact.
Thanks, David. Thanks so much for sharing. And we really can't wait to see where this collaboration will take us. Okay. Now that we've heard about HyDesign's functions and saw what it can do with examples of real end-use parts coming along, nothing really beats witnessing the software live at work. And for that, I'd like to introduce everyone to Moritz, our Director of Engineering at Hyperganic, to run you through a live demo. Moritz, please.
Thank you, Linhan. Hello, everybody from my side as well. It's very good to see a lot of known names in the list of attendees. So warm welcome to everybody here. Yeah, so David, if you're searching for people to test your saddle, I'm definitely all in. I'm a little bit of a road biker myself. So what I'm going to show you right now is essentially a 4-step process. I'm going to import a base geometry of a midsole into HyDesign, apply latticing and demodulation driven by a grayscale map, select suitable lattice structures from the Forward AM validated lattice library, and then generate latticed midsoles and make them ready for exporting. So I'm going ahead and sharing my screen. So you should be now seeing my screen, and you see the launch window. That's the area that you see right after you signed up for your account in HyDesign. Brief overview, you have your account settings up here. You have the overview where we are right now. HyDesign as a product is here, and the HyDesign documentation you find here. How to access that, I'll show you in a second. So let's launch HyDesign, and we'll see the projects that me and my team have. In this case, I am all alone. So I could, of course, filter my projects, but I'll only see my projects, and the view doesn't change essentially. So for today's sake, let's create a test project. Or let's just call it HyDesign launch. Hello, everyone. Create the project. And here you see the outlook of the product, the viewport, as some of you have already seen in the public beta phase. Then in the top bar, we see the menu where we can do adjustments to the render color, import, export, create primitives, apply shells, construct solid geometry operations. Then we have translations, a standard set of translations, rotations, and then here the space filling algorithms such as TPMSs, adding pattern to TPMSs, modulations, as well as lattice fields. And of course, analysis tools such as volume analysis. Information about the product can be found all the way on the right. Of course, here, if you find anything that you don't like, report an issue. If you see features that you love and you would like to extend on them, request a feature. So I'll import a volume file as indicated before, in this case, a midsole. While this imports, you can see that the project tree on the right side is updated. So you see all your actions that you performed on an object are stored here. I then go ahead and I infill this object with a lattice fill. In this case, let's start only with a uniform lattice structure. So, okay, what lattice do I want to choose? In order to find out, you can go to this information symbol here, either click the symbol and you would immediately find the lattice library, or if you want to learn more, then you will be redirected to our documentation that explains step by step how to perform actions in our tool, HyDesign. So since we are in the footwear in the footwear field right now, let's select footwear. Select one of the lattice pads indicated here. So A1 shore hardness below 27 seems to be the right one for my task right now. So I'll apply lattice pad footwear A1, confirm. Let's have it process. And you see within seconds, the tree is updated and the lattice is applied. It just takes a brief moment for the rendering to update here as well. So here we have the lattice. Of course, you can do much more than that. Let's now add a modulation to the lattice using a grayscale image. I therefore import a grayscale map. This is a little bit of an extreme example, of course, but it really clearly indicates the effect of the grayscale map. What you will see now is that in the white areas, the lattice beams are going to get thickened up to the maximum thickness, while the black areas remain at the initial thickness. And everything in between, essentially everything that's gray, would stay as it was. So let's make this a little bit larger here. Something like that. We start from stiffness number 1. We go to stiffness number, let's say, 4. To select 4 here. Let's have a brief look. Okay, this is a shore hardness between 40 to 54. And let's confirm and run this adjustment in the lattice structure here. And you can already see the changes to the lattice structure. You can see that in this region here, if you follow my cursor, the lattice is much denser, much thicker because the beam thickness has been adjusted accordingly, while in the black areas, it hasn't changed at all. You will also notice another hint here up here. This is something that I won't demo today, and I leave it to you guys to explore yourself what might be behind this magical simulate button. Before we end, I'll quickly go and show a few more features that are within HyDesign. We have the infilling, of course. You can do constructive solid geometry. I'll show you as well. I'll show you also what it looks like if you add a pattern to a TPMS. So here we have the TPMS infill, and we are going to merge this into a sports primitive. Along the x-axis, we have a predefined gradient from 40% of the length to 60% of the length. Let's add that in. So that in the forefoot area, we should have an even sparser lattice, which could be a property that might be desired by the footwear designer. So here we see the changes already applied to the midsole with the gradient between the structures. Again here, small hint, there's this magical simulation button that I leave you guys to explore. So with that, I would like to give it back to Linhan, and I hope you guys enjoy exploring HyDesign. Thanks.
Thanks, Moritz. Now, in that live demo, we saw how design flexibility and validated material are all packaged in an app that takes minutes to master with a magical simulate button, making the development of a 3D printed lattice part much more accessible than ever before. But we're not stopping there. I'd like to bring Michael back to share about what's on the horizon for HyDesign. Michael, please.
Thank you, Linhan. While we are very excited to be officially releasing HyDesign today, this release is just the first step along the road to delivering our full product vision. We are building a unified design, simulate, optimize loop in a single, easy-to-use application. With HyDesign, we want the expanded design space that is possible with additive manufacturing to become more accessible to product designers and engineers as they develop functional end-use parts. Here you can see our roadmap for integrating a full suite of multi-physics simulations into HyDesign. Today, as seen earlier, we have the beta pre-release of linear elastic structural simulation. In roughly 2 months, we plan to release thermal simulation. This is particularly important in metal-based additive manufacturing parts for industrial applications. Next, we're developing our own Lattice Boltzmann fluid dynamics implementation, which we are already using internally. We plan to integrate this CFD capability in HyDesign in approximately 4 months. This will include thermal analysis, convective flows, multi-phase flows, and phase change evaporative cooling. Finally, on a somewhat longer timeline, we are working to integrate simulation for nonlinear and plastic deformations for polymer material models. This simulation is perhaps the most technically challenging, but it is very important for developers of 3D printed plastic structural parts. Here, we have screenshots of Highlight, our current technology demonstrator for an integrated design simulate optimize loop. Highlight is a standalone lightweighting application that uses simulation to optimize the strength to weight ratio of 3D printed structural parts, in this case, a mounting bracket. The initial part is first loaded and an appropriate lattice fill is applied. Next, the boundary conditions for the required load-bearing capacity of the part are specified. Finally, iterative cycles of simulation and optimization are used to refine the lattice geometry until the part satisfies the strength requirements without using excess material. In addition to this, Highlight also has the ability to generate TPMS structures that are modulated and optimized according to the results of structural simulation of stress and strain. This all happens within one tool, and once the boundary conditions are specified, it requires no further user intervention. We are working to integrate these optimization loop capabilities into HyDesign this year. HyDesign Standard Tier is available today on a monthly subscription basis. After an initial no obligation 14-day free trial period, the subscription will be 50 euros per user per month. The standard tier includes all the features we've demonstrated today, including unlimited exports and beta pre-release access to our structural simulation feature. The Pro tier, which will be coming later this year, will include everything in the standard tier, along with access to advanced features and the full release of our multi-physics simulation suite. Thank you, everyone. And now we will open up the discussion for any questions you may have.
All right, and with that, we'd like to open up the floor for questions. If you have any question at all, please ask them using the Q&A sections found at the top ribbon of Microsoft Teams, once again. And if you'd like to share a thought with us verbally, please raise your hand, click on the raise hand button, also found on the top ribbon of Microsoft Teams, and we will enable your unmute button. And in the meantime, please feel free to scan the QR code here to sign up for your 14-day free trial. Further, if you'd like to stay connected with our developments, scan the QR code on the bottom left to follow us on LinkedIn. Now we'll start by addressing the unaddressed questions in the Q&A sections that we've received during the presentation.
So we have a question from, I'm sorry, this is going to be butchering the name, but Naim Adin. Is it possible to conceive solid and sheet TPMS structures, for example, solid gyroid and sheet gyroid? The default is the sheet gyroids. Those are the most commonly used. And we have the ability, which we are currently improving, to modulate the bias and wall thickness to get everything between a sheet gyroid and a solid gyroid. So this is a capability we have, and it's being improved as we speak. So you can see there.
As a default, just to add on to this, as a default, if you go to ISO value 1, you will switch away from the sheet gyroid to a solid gyroid with the improvement that Michael was just mentioning, allowing you to do this similarly like you would do a normal grading. So in this case here, I would need to select a smaller cell size of this gyroid. Let's do that so you can properly see as well. Let's have this calculate for a second and wait for the rendering to update. So now you see that in this case here, the gyroids, you're closing off the channels, the further you increase this value here. So through the setting of an ISO value, you will be able to control if your entire structure is a sheet-based or a solid gyroid. Of course, any type of TPMS.
Okay, thank you for that demonstration, Moritz. Will Halden asks, how do you get the white background? Mine is black and I can't find where to change it. It is possible. So there is an issue with certain browsers, and I've encountered this myself on Linux, where you end up with a black background. You can follow up with our customer support, and we will get back in touch with you and see if we can help you resolve this issue.
Yep, customer support email is hello@hyperganic.com. Oh, sorry, support@hyperganic.com.
Support@hyperganic.com. Thank you, Linhan. So we've got that question answered, and there was a question about a educational license. So at the moment, we do not have an educational option, but we will be rolling that out in the next couple of months. So stay tuned. And if you want to be notified, you can also send a note to support@hyperganic.com, and we will put you on our waiting list for educational options. And we have Emmett Sharma, okay, and wants to know if we will be able to simulate supersonic flows. Sadly, we will not be supporting supersonic flows. Currently, we are focusing on incompressible flows. So that means effectively gas flows below Mach 0.3 roughly, and then fluid flows is a main focus. So we're not, at least in the short term, looking at supporting flows much beyond Mach 0.3, because then it gets it's a little bit niche, the thermodynamics that are involved in that.
Michael, there's a question from Abed saying, can we use the program as a software, not in the website only, like a 3D software? So I think he means on-premise.
Yes, so we do have the option of on-premise installation, but this is something that we do for enterprise partners. It is, certain applications in aerospace, particularly defense, they will not use cloud-based applications, and we have special provision for that type of customer. But for individual users, at the moment, we only offer the web-based version. Linhan.
So there are two questions from Panos. So number one is, are we implementing a lattice structure in 2.5D, meaning you can machine it with a 3-axis CNC machine? He'd like to know if we have any update on that.
Not really clear on the... So we do not have support for beam lattice, like 2.5D beam lattice that you could use perhaps like on a 5-axis mill, 6-axis mill. That's not something that we've envisioned, although for some of the TPMSs, assuming that you adjust the height and unit cells of your fill, you would be able to get machinable TPMS structures within the limitations of your particular choice of TPMS. So this isn't something that we have seen a lot of demand for and haven't provided for, but you can do within the limitations of the geometry, the inherent geometry. So if you wanted to do, for example, a TPMS machined surface, you would be able to control that with the existing modulation.
Okay.
And Adim wanted to know about the ISO value. The ISO value is basically how far from the edge of the TPMS we're filling in. So the larger the ISO value, the farther away from the edge will be filled.
There's one more question from Joe. Joe asked, is there any way to identify non-attached islands of mass so they can be eliminated when the export is off to the 3D printers?
Okay, that's a very good question. We have implemented that as a processing step for a simulation. And we have that capability internally. And at the moment, it's not a button you can click, but it probably will be very soon.
David asked, is there an API available to automate some of the operations?
There is no API available to automate the operations at this point in time as a public API. This will be something that will be offered as an advanced feature. For our algorithmic engineering customers, we do offer API-based workflows for integrating into third-party applications. This is actually an active area of product development for us, and we have a number of customers we're working with to do that. So if you have a specific application where you would like to embed algorithmic capabilities into a third-party application, we'd be very interested to hear from you. But at the moment, there is no publicly released or supported API for controlling HyDesign at this point in time. But there will be at some point in the future, maybe later this week, maybe later this year.
What about surface textures? Will Holden ask, is there a roadmap for this feature?
So right now, today, if you have your own grayscale image of what your texture is, so basically a depth map, you can already apply textures to your parts. In terms of a library of repeating surface textures that you can just pull down from a menu and apply to a surface, that's in the backlog. It is not released today.
Okay. And Afro asked if it's possible to design water membrane separation with flow design optimization, ceramic membranes as an example.
Okay, ceramic membranes with flow and diffusion is not something that's available today, but it is something that we are actually working on today as part of our Lattice Boltzmann CFD. And this is something that we're looking to bring into HyDesign this year.
All right. Priam Givod asked, when building a car wheel structure, can we have simulations on outside forces on that wheel as well as torsion
So
when accelerating?
Torsion when accelerating. So at the moment, so there's 2 points here. One is at the moment in the beta release, our simulation, at least today and perhaps for another couple of weeks, there's limitations on the size of the part that you're able to simulate, and a car wheel is likely to exceed that. The second question around torsion. So at the moment, the way that you would simulate torque as a boundary condition is effectively the way that it's done in many other simulation tools, such as, for example, you would find on SimScale, which is you have to do 2 or more radial opposing force boundary conditions symmetric around the axis. And that can give you the torque. There isn't a built-in torque boundary condition at this point in time. There may be one to come, but at the moment, we're doing basically what other third-party tools do.
Name asks, is it possible to export the TPMS structure to another software?
You can export the TPMS structure as a mesh file. So for example, STL or 3MF, and this can be imported, but there are a number of important caveats. Unless you're using a tool that has very good support for manipulating meshes, such as, for example, Blender, it may be difficult to work with. And secondly, by the nature of TPMSs and beam lattices, when you convert them to a triangular surface mesh, the size of the file grows very, very large, very, very quickly. And so I will just caution that it will be very easy inside of Hyperganic to create a part which, when converted to a surface mesh, is too large for a third-party tool to import. We are aware of this problem and looking for solutions. But for normal size parts, that don't have very aggressive latticing, particularly beam latticing, you can import them into a tool that can process and manipulate any other type of surface mesh. We export to a variety of different industry standard file formats: STL, decimated STL, decimated STL, 3MF, decimated 3MF. These are the most popular form. We do not export to step files that would be used in a BREP CAD package, such as Creo or Fusion 360.
On this topic, Priyam Givot follow up with a question: What about a voxel export format and like a bitmap stack?
Yes, we can export as stacks of PNGs. We can export as VDB files for the OpenVDB format if you want volumetric.
Okay, coming to an earlier question by Thomas Cornett. He finds that once he exports his files as STL, there's a significant decrease in quality, and he asks if there's a preferred export format for optimal mesh quality.
That would be very interesting to get more feedback on. So I think the preferred export format, and Moritz, feel free to weigh in here, would be 3MF if you want the best fidelity. And then we offer, if the 3MF is too large, then decimated 3MF.
Yeah, nothing to add there. Of course, the highest quality of the part would be achieved by having an undecimated export. Then there's almost no error between the, let's say, voxel-based representation and the mesh-based representation. Whereas if you decimated, your file size gets lower, but at the same time, you introduce a small error or ever so slight error, depending on the grade of decimation. If you decimate your file very heavily, of course, you might increase the error there.
And thank you, Moritz. And I would just add to that, if your experience is different from that, if you are exporting in non-decimated 3MF or STL, and you're seeing significant deviations from your original geometry after applying a fill, please get in touch with us at our support, and we will look into that and ensure that there isn't something going wrong on our end.
Okay, Panos clarified on these previous questions for a 3-axis machining. He was asking for something like a variable density honeycomb structure that is specifically for 3-axis machining. Moritz?
So in fact, actually, this has been a function we used to have. It hasn't been requested much, as Michael was mentioning before, so we didn't put it into HyDesign. We do have 2D lattices such as the honeycomb that we could make available in the product. Ideally, let's have a call sometime after this with one of our product guys, Weijier or Lin Han, to scope exactly how this function would need to behave, and then we would put it on the backlog, of course.
And thank you, Moritz. And his second question is, do we have any function that defines non-modifiable geometry, such as a boat interface?
I quickly go ahead and answer that one too. So what you can do is you can, of course, go ahead and shell an object. Then your surfaces, all your functional surfaces remain intact. And you would only create an infill in the inner region. So let me maybe bring up an example and show you what this would look like. Just a very brief moment. So I'll share my screen quickly.
And while Moritz is doing that, I'll add that you can achieve almost any type of attachment for fasteners or structural parts using constructive solid geometry. So you can take sections and cross sections and intersect and union and build up your desired part with the solid and with the filled as your application requires. So we have a full set of Boolean operations.
Yeah. So here you see it, an infilled mold. Of course, this is not optimized for thermal conduction here. So everybody in the field of molding, please forgive me, it's a demonstrator. But you see the blue is the TPMS infilled, in fact, even a merge between gyroid and S surface. And then on top, we have the functional surface completely left intact by applying the shell feature.
All right, Kevin asked, could we hope to see nonlinear stress analysis for simulation of lattice structures?
Yes, that is, as I mentioned earlier in the roadmap, that is a particularly challenging area because in addition to the intrinsic challenges of nonlinear finite element analysis, there's also the issue that when you're dealing with simulation and deformation of lattice structures, you need to account for self-contact. So simulation of nonlinear deformation with self-contact is it's kind of at the edge of scientific research, and we are working towards that. That's an objective, but it is a challenging simulation type category. And but we recognize the importance of it for people developing 3D printed polymer parts, and it is in our roadmap, but unfortunately it's not available today yet.
I would just like to add here, if you have any, let's say, if you're looking for any elastomers like the TPU01 for MGF or TPU88A for SLS, those are materials that are heavily nonlinear. And for those, we do provide the material models or any kind of simulation support. So this is something that we provide, but also, of course, help and work together with Hyperganic to integrate that into HyDesign, so this becomes easier to use as well.
Yes, that's very important. As Marius said earlier in his introduction to Forward AM, they do have a full range of consulting services. So if you have a particular application that you have in mind and you want to get simulation, they've, for example, been working with protective sports helmets manufacturers to do highly tuned material and lattice geometries for lightweight, highly effective cushioning. So for that type of application, definitely be in touch with Forward AM.
Okay, Huang Jiaozhao asked, can the overhang constraints be applied in the lattice design?
At the moment, we do not have integrated design for additive manufacturing constraints. We don't have automatic support generation. The most common area of application for the beam lattices is in powder fusion, where actually depowdering is much more of a concern. Design for depowdering is much more of a concern than overhang constraints. So this is, again, something that is down the road in our roadmap to be able to include these sort of design assistance, DFAM assistance for non-powder processes. But again, it's not in the product today. It's in our product roadmap.
Okay, Kieran Jones Ted asks, for TPMS such as gyroid, can we create inverse geometries? For example, if making a solid domain, he wants to create the fluid domain.
He wants to create the fluid domain. Well, so the thing about TPMSs is they're inherently symmetrical. So if you can create one in one direction, it's the same as creating the other in the other direction. You have two split domains. Maybe I don't understand the question fully.
Okay. Moritz?
Fritz.
I'm reading between the lines here. I guess what this question is going for is if we have a way to identify one domain. Let's say if there's a TPMS applied for a heat exchanger, where you have one side being the hot domain, the other side being the cold domain, and if we can make these domains available in the product. If that is the question, I'll just go ahead and ask and answer. At the moment, it's not yet in the product, but it's very close.
Yes, so we're working on that and expect to have that included in the next couple of weeks.
All right, do we have stamina for one more question? All right, Steve Cock asked, is there a minimum subscription period?
The minimum subscription period is 1 month. It's a monthly recurring subscription. You're able to cancel at any time, and you get a 14-day free trial. We want to make this very easy for people to try out, and if they're happy with it, to be able to use it as long as they're happy with it.
All right, that's perfect. And that's it. Hope you've enjoyed learning about HyDesign and how it makes Lattice design effortless. We'll send the recording and some follow-up information to you guys via email. Thanks everyone for your participation, and have a great rest of your day. If we haven't managed to answer your questions, please reach out and get in touch with us through LinkedIn or through our support email, support@hyperganic.com. Thanks everyone, and see you next time. Bye.
Thank you. Bye-bye.
Thanks, everyone.